The next unit that I would like to go into, or the next subject in this unit of soil physical properties, is the topic of soil structure. So if texture, which we've spent our time on up to this point in time, is the percentage composition of sand, silt, and clay in a soil, structure we can define as the geometrical arrangement of these soil particles into either semi-stable aggregates or clods. So structure then, simply put, is how do these particles fit together into aggregates or clods, and what is the general stability of this aggregate formation in the soil? In order to understand what promotes the development of structure in a soil, we need to look at the two basic processes involved in soil structure formation. The first of these processes is more of a chemical process, and it's called flocculation. Flocculation is saying that, as I started to describe earlier, soil particles have negative charges at their surface. They would naturally want to repel each other, except for the fact that we have cations, positively charged particles, that get in there between these and help hold them together. So the mutual attraction of these soil particles for a positively charged cation is what causes them to flocculate, or these individual soil particles to have a tendency to want to be attracted to each other. Well, I think you can see that if we had soil ions, cations in the soil, a high content of these, which had more than one positive charge, especially the divalent ones such as calcium and magnesium, these types of cations in the soil are very effective in helping to promote soil flocculation. If, however, we had a high percentage of cations in the soil that had only one positive charge, and in this case I'm thinking primarily of sodium, soils that are high in sodium have a tendency to not form good structural units. And part of the reason that they don't form good stable structural units is because of these monovalent cations, such as sodium with a charge of +1, dominating many of the exchange sites on the surface of the soil particles. And they only have one positive charge, which can kind of help attract particles to each other, but it is not nearly as effective as those soils whose cation exchange sites are occupied primarily by the divalent calcium and magnesium cations. So that's the first process that helps promote structure formation and development of structural units in soils, and that process again is called flocculation. A more simple process, one that we can really think of as being like a cementing type of effect, where we're taking soil particles and helping to adhere or glue them together, so to speak, and that process is called aggregation. Soils or substances which promote aggregation in soils are things like lime, calcium carbonate, acts as a cementing agent, organic matter, and especially the decomposition of the organic material, the humus, acts as a very great stabilizing effect on helping promote aggregation in the soils. Root exudates, materials that as roots of plants grow in and pass through the soil, they are crushing epidermal cells, they are exuding exudate type materials from the surface of these roots. These all help serve as cementing or aggregation agents that help hold these soil particles together. So lime, organic materials, especially root exudates, microorganism gums, the byproducts of the breakdown of organic material by the microorganisms. Some of our highly weathered clay minerals like iron and aluminum oxides help also to promote this process of aggregation in the soil.